Hey, hello everyone. Today we are going to learn about Maths Practical number 2 matrices. That's from Vidxii Science and Arts Mathematics Practical book published by Maharastra State Board. So let's go. Now why matrices in 12th? Matrices is being important in many topics whatever you go for higher studies like computer graphics, robotics, engineering, physics, graph theory, data analysis, cryptography, algorithm and many more. So that's why the topic is included in 12th. Now what we have already learned in 11th was algebra of mathematics, and here we are going to learn about finding inverse by two methods, of course. Elementary transformation, again there are two methods, row transformation, column transformation, and second method to find inverse is adjoint method. Also we are going to learn about the solving simultaneous equations. Here we have two methods, inversion as well as reduction method, and students' favorite is of course reduction method. Okay, let's start with the practical now. It starts with the result to be recalled. Here, whenever two square matrices on multiplication gives you the identity, either way AB or BA, then they are called the inverse of each other. And of course, we denote the inverse by A inverse. A has to be a non-singular matrix. Then A inverse will be what? 1 upon A inverse into adjoint of A. Now, inverse does not exist for a singular matrix, that you have to remember. Your example 1 and 2 both are being solved. First is based on row transformation as well as column transformation. Second is based on reduction method. You can go through that, and any difficulty you can contact your teachers. The third problem now starts. As A is a given matrix, verify A into adjoint of A equal to adjoint of A into A, and that will be equal to matrix determinant A into identity matrix. Here identity will be of third order, 3 by 3. So solution starts with A. Now you have to find the determinant of A. You remember we had done this in 11th. Determinant A will be equal to A11 into the determinant of the numbers which are left when you eliminate first row and first column, then minus second element A12. Same way the determinant of the left out elements by eliminating first row and second column, and same way third. So you remember this, right? So here we get the determinant of A value, that's 7. 7 is what? Non-zero, right? So that's why inverse exists, and we can find adjoint also. Determinant A you are given as filling in the blanks, so complete this. You can pause the video anytime and complete. Okay, let's go further. So we have to find minus and cofactors. What are minus? Mij. That's the value of the determinant you obtain by eliminating the row and column in which I and j lies. Aij lies, and Aij is what? Minus 1 raised to I plus j into Mij. You very well remember this. So we need to find A11, A12, A13. Let's go. This is your matrix A. A11 will be what? The minus 1 raised to I plus j, that's 1 plus 1, and determinant of the, that is minor of A11, that will be this part. Similar way A12 and A13. Okay, so you can pause the video and copy this. So similar way we have to find A21, A22, A23 as well as A31, A32 and A33. So here are the solved part. You can copy. You know how to find this. A21 will be minus 1 raised to 2 plus 1, and the determinant which we obtain by eliminating second row and first column. Okay, that's second row and first column. So minus 1, 2, 0 and 3. Okay. So here what you have to fill up in the book. So for that we'll require all the elements. Here we display all the elements A11, A12, A13. This you have to write row wise, and that makes you the matrix of cofactor. These are filled up. You have to fill up the last one. They are this. Okay, and transpose will be obtained by writing the matrix of cofactor as row to column. So first row becomes first column, second row becomes second column, and third row becomes third column. So do it first and then check with your answer. Correct? Okay, let's go further. Now we have to multiply two matrices A as well as adjoint of A, which we already have found. A was already there. Adjoint of A we found, that is the matrix of cofactors. How do we multiply two matrices? First matrix row 1, column 1, row 1 will be multiplied with column 2, and row 1 will be multiplied with column 3. Same way, row changes. Again, second row you have to multiply with each of the 3 columns, right? A into adjoint of A, let's multiply. So here, first row into first column, first row into second column, first row into third column, and similar row changes and the similar procedure. That's how we multiply. This is already you have done in 11, so you can go fast in this. And we get the multiplication as this one. So you are getting this kind of matrix. What kind of matrix is this? When you have diagonal same elements and non-diagonal elements is 0. That is called scalar matrix. You can take the common element out of the matrix and this becomes the identity matrix. So it is 7 times A, and 7, remember what was the value? 7 is determinant A. So we got one side result. Similar way we have to prove the other way also. Adjoint of A into A. Adjoint we found, A was given. Same way, row into column and get the matrix multiplication. We get the similar result, same result actually, 7 times AI or determinant A times I. So here what we have verified. Okay, now the fourth example. Here we are given the matrix A. You need to find A inverse by elementary column operations. Column operations are being rare, so being tough, because we are very comfortable with row operations. But remember, they are asked at the board exams. All the sums which we do for the practical exams are equally important for your board theory exam as well. They can be asked anywhere, like theory exam as well as practical exam. So not to ignore any of the sums from the practical book. Okay, so here again, first we find the determinant. Now you are very comfortable at finding out the determinant, so do it fast on your own and then check. Again, non-zero, so A is non-singular and hence A inverse exists. This part is being printed. Okay, so you have to fill up the blanks. Okay, so for column operations, what do we have to keep in mind is the operations are being done on the second matrix only. Okay, remember this. Same as row operation, whatever we perform on left side, we have to perform on the right side also. Target is the identity right now. And direction of operation goes in this manner. What does that mean? We have to get A11 first 1. Then using C1, we'll be getting A12 and A13 0. Then you concentrate on these 4 elements getting 0 or 1 as required, not using C1. We'll be using each other, C1, C2 and C3. Okay, and then you'll get A21 0 using C2 and A31 0 using C3. So let's go. Okay, now for column operations, we always write A inverse first, then A and is equal to I matrix. For row operation, it is the other way, right? So we are going to perform on this matrix. Remember, our target is what? Identity matrix. We need 1 here, it is already there, so bonus. So then we are making this 2 zeros. 2 minus 2 makes it 0. 3 minus 3 makes it 0. So our operations will be what? C2 minus 2 times C1, C3 minus 3 times C1. Right? So what is going to change now? Only C2 and C3. And whatever operations we perform on left hand side, we have to perform on the right hand side also. Don't forget. Okay, so many times students forget to operate on the right side, and that's where they make the mistake. So you try that. This is already done for you. Try or doing on the right hand side. Same operations. C1 will be same. C2 will change and C3 will be changed. Here's the explanation if you need an understand. So here what we did is 2 minus 2 times this, 1 minus 2 times this, and 4 minus 2 times 2. So that makes the second column, that's 0 minus 1 and 0. And this is how you get the third column. Now similar operations we have to perform on right hand side also. That's where we get 1 0 0 will be remaining same. C2 is changing. 0 minus 2 times C1. Okay, 1 minus 0, 0 minus 0. And here third column minus 3 times C1. That gets you this result, minus 3, 0 and 1. Now we have got minus 1 over here. 0 is a bonus. Next 0 we didn't plan, but we got it. So next thing is we make this minus 1 as 1. How do we make that? By changing the sign of C2. So change the sign of C2 on either side. Here we are to change C1 and C3 will remain same. Only change the sign of C2 and write here. And here it is already done. This was minus 2, 1 and 0. So it becomes now 2 minus 1 and 0. Whereas first and third columns remains same. Okay, so first and third are not changed. Second is changed by changing the sign. Got up to here? Okay, next. Now what is the next operation? We got this. Now you have to get what? Here 0 and here 0. So that's done by C1 minus C2. And now C2 you are using, so C2 is not changed. Okay. And C3 is also changed using, and here we are trying to get what? Zeros. So the operation is what? C1 minus C2 and C3 minus 2 times C2, so that we can get over 0 over here. So C2 is not changed, C1 and C2 are changed using the operation. Now you can write down the right side. Next operation is to make this 0, that is 2 minus 2, that means using C3, and you get 2 minus 2 times 1 and rest all of what? Not changing. So here you'll get 1 0 and 0, and this is changed accordingly. You will be changing what? C1 minus 2 times C3, sorry, this one. So minus 1 minus 2 times minus 7. So that's what? Minus 1 plus 14. That gets you 13. And the rest elements. 1 minus 4. That's minus 3. 0 minus 2 minus 2. And here we need to fill up the blanks. Only this thing is changing. That's why we made the operation. Next step. We got the inverse now, because any matrix into identity is what? The matrix itself. And here we get our target is done using column operations. Clear? Okay, let's move to the next one now. Fifth sum. What are we given? Show that this matrix is invertible. Find the inverse by adjoint method. So there are two parts. First we have to show invertible. How do we show that? This has to be what type of matrix? It has to be non-singular. So obviously we have to find what? Determinant first. If determinant comes out to be non-zero, then only the inverse exists. The rest part will be after that. If it is a non-singular, then we'll go for finding inverse. And this time it is using adjoint method. So first we find the determinant A. Now we are comfortable. Find it out and check your answer. So obviously it is non-zero, and that's why A inverse exists. Now we find the minors and cofactors. Again, similar way as we had done earlier. Okay, A11 is minus 1 raised to 1 plus 1 and the determinant obtained by removing the first row and first column. A12 minus 1 raised to 1 plus 2 and the determinant which is obtained by removing first row and second column. So you try yourself filling the blanks and check your answer. You can copy this by pausing the video. Done? Now matrix of cofactor, you need to write row wise first. These are the elements we got. Okay, we write first as row wise and then get the transpose of the given matrix. First row becomes first column, second row becomes second column, third row becomes third column. So write that way, that becomes your adjoint. This is your adjoint. Okay, as it is a symmetric matrix, it is not affecting whether you write row wise or column wise. Now how do we find A inverse? It is 1 by determinant A times adjoint of A. So filling the blanks now, you have the value of determinant A as well as adjoint of A. And that's how you are getting A inverse as this matrix. Okay. Next. Now you are given A and B and you have to find matrix X such that it satisfies this matrix equation AX is equal to B. Now what is the order of A? It's 3 by 3. B is 3 by 1. So what has to be the order of X? It has to be 3 by 1. Right? Now we have to find X by solving this matrix equation. So there are two methods. First method is transforming A to I. Okay. And if we are transforming the first matrix, what are the operations? Obviously row operations. So we do row operations and transform A to I. So we directly get then X is equal to B. So B will be transformed as we do operations on A. So this is first matrix, that is your A. X is equal to the target matrix. Now row operations, we go in this direction. Okay. So here we'll get first one, that is bonus we already have. Now thing is we have to make this to 0. So how do we make minus 1 to 0? By adding 1. And how do we make 1 to 0? By subtracting 1. So the operation will be R2 plus R1, that makes this 0, and R3 minus R1, that makes this 0. So perform these two operations and write down. Similar operations you have to perform on the right side also. So minus 6 minus 3, that gives you minus 9, minus 9 minus minus 3, that is minus 6. Next thing, we have to get 1 over here. So second row divide by 3. Same operations on right hand side. Write down this much and then we go further. Now next operation, we have to get this to 0. Okay, so we have got the R3 as 0, 0, 1. Now we have to make this 0 and this 0. So 5 by 3 minus 5 by 3 makes it 0 and 3 minus 3 makes it 0. So we multiply this by 5 by 3, subtract from R2. We multiply this 1 by 3 and subtract from R1. So R1 and R2 are changing and R3 will be same. Similar way, R3 is same here. R1 and R2 are changing. Now what is left? Only this 2 to be made 0. That is using R1 minus 2R2. Similar operation on the right hand side. And now we got the matrix X, which has to be 3 by 1. We got it as the column matrix 1, 7, minus 6. That's your answer. This is another method. Here we can find, we multiply both the sides by A inverse and X will be what? A inverse times B. Of course, this will be a lengthier method. So we find first A inverse using adjoint method. For adjoint method, you can write down this way: 3 column Aij, Mij and capital Aij. Write all the elements here, then write the matrix of cofactors, its transform, determinant A, that will be first 3 element into first 3 element. That means A11 into A1 capital A11, A12 into capital A12 and A13 into capital A13. And then A inverse is this. Now multiply it with B, pre-multiply. Okay, don't forget you're multiplying on left side. So it is called pre-multiply. And that's how we are getting X, same result but by another method. Now okay, so here we come to the last sum of the practical. Given matrix A, you need to find a matrix B such that on multiplication with A gives you I, and also the other way it should happen. So this is only happen if B has to be what? Yes, you guessed it right. If it is an inverse, A inverse, then we will get this result, right? So if A is non-singular, B will be nothing but your A inverse. So first we check A is non-singular by finding its determinant. Determinant comes out to be non-zero, so A inverse exists. We find A inverse using the row operations. A into A inverse is equal to I. Here we write A first and then A inverse. The operations will be done on the matrix A. Okay, the order of the row operation goes in this direction. So it will be exactly the reverse than the column operation. So first we'll have to make this to 0 because this 1 is already done. Okay, so how do we make this to 0? 5 is made 0 only if I subtract 5. So my operation for R2 will be what? R2 minus 5 times R1. We have to use R1 for both the rows. Similar way, 1 will be made 0 if I subtract 1. So the operation will be R3 minus R1. So after operations, what we get is this. Similar operations you have to perform on second side also. Now you have to make this 3 0. Obviously 3 minus 3 is 0. So we use this 1. So operation will be R3 minus 3 times R2. That gets you 0 over here. This becomes an identity matrix. So A inverse is obviously the final transform matrix. And that's nothing but our A inverse and also the B. Correct? Now after getting B, you can show A into B is I. Also B into A is I. Hence verified. Thank you. Until we meet again. Bye.